Okay, you learned in the last two pages what happens as you go left to right, what increases or decreases as you go from left to right across the period, and what happens as you go from right to left across the period. All right, this video we're going to learn what happens as you go down a group from top to bottom. Okay, and the first thing I want you to do is draw two arrows. Draw an arrow going right to left, and an arrow going from top to bottom like that. You can draw that on the very top of the page, above everything. What that means is, usually whatever increases or decreases as you go from right to left will also increase or decrease as you go down a group. Okay? But there are three exceptions. I put stars next to those on the page. There are exceptions. But for the most part, everything else, whatever increases go from right to left also increases as you go down a group. And whatever decreases as you go from right to left also decreases as you go down a group. So next to the two stars, I want you to write the following. Usually whatever increases or decreases as you go from right to left across a period, usually whatever increases or decreases as you go from right to left across a period will increase or decrease as you go down a group. Will increase or decrease as you go down a group. Usually whatever increases or decreases as you go from right to left across a period will increase or decrease as you go down the group. Okay, so I'm going to choose group 1. Okay, so I'm going to, group 1, I'm going to start with Li. You don't count hydrogen, hydrogen by itself. Alright, so start with Li. What's below Li? Na. So Li, Na, K, Rd, Cs, and Fr. Alright, so I'm going to go from top to bottom and see what happens to all these things. Alright, so atomic number. Again, this is one of the exceptions that does not apply to this rule here, the left and down rule. Alright, so Li's atomic number is 3, Na is 11, K is 19, Rd is 37. You can see what's it doing? Increasing, so draw an up arrow. Nuclear charge, same thing as atomic number, draw an up arrow, increase. Okay, now valence electrons, in a group it's totally different than a period. Li has how many valence electrons? 1. Na, how many? 1. K, how many? 1. What's it doing? It's remaining the same. That's what defines a group, the number of valence electrons. So valence electrons draw a little sideways arrow for it remains the same. Okay? So valence electrons remain the same as you go down a group. Okay, so now the next ones, the next three you need table S for: ionization energy, electronegativity, and atomic radius. Okay. All right. So basically, I usually just take the top element and one of the bottom ones. So let's just compare Li with Cs, and you just by comparing those two, you can tell if it's increasing or decreasing as you go down a group. All right. So let's start with lithium. So ionization energy of lithium is 520. All right. All right, I'll draw a couple. So let's do a couple more. Sodium 496. Potassium 419. Okay, so you can see it's already decreasing. And I'll just go down to CS to see how much it decreases by. And CS, you get 376, very extremely low ionization energy. CS 376. Okay. All right. So what's it doing? As you go down a group, it's decreasing. All right. And next, electronegativity. Electronegativity is next to ionization energy. So you have 1.0 for Li. Na 0.9. And K 0.8. What's it doing? It's decreasing. So I draw another decrease arrow for electronegativity. Now, atomic radius. Atomic radius, go to the last column. Okay. The atomic radius of Na is 160. And go down to K. 200. Sorry, I skipped NA, didn't I? Li, no, sorry. Li is 160. K is 200. Let's go up a little bit. Right, okay. Li was 130. Okay, I got it wrong. All right. Li is 130. There you go. Na is 160. K is 200. All right, so you see it's increasing. I apologize for that. Li is 130. Na, atomic number 11 is 160. And K, atomic number 19 is 200. So, atomic radius is increasing as you go down the group. Draw an increase arrow. Okay? And what did I say before? Where are the most reactive metals found? Most reactive metals are found in the lower left region. So the further left you go and the further down you go, the more reactive or the more metallic properties you get. All right? What do you mean by more metallic? I mean lower ionization energies, easier to pull an electron away, and lower electronegativities, lower ability to gain. Okay? So the most reactive metal is Fr. So as you go down a group, Na is more reactive than Li, so Na is more metallic than Li. K is more metallic than Na, because it has lower ionization energies, lower electronegativities, and bigger radius. Rb is more reactive than K. So as you go down a group, metallic character increases, and non-metallic character decreases. That's the last two. Metallic character increases, non-metallic character decreases. Okay. All right. So as you get more metallic, you have lower ionization energies and lower electronegativities. All right. So you're getting less ability to gain electrons, less electronegativity, and it's easier to pull an electron away, so you have lower ionization energy. All right. So let's answer those questions right now. You have 3 questions on the bottom of the page. All right. The first 2 are opposite of. Basically, actually, what you can do is save time. The answers to the first 2 questions on the bottom of page 10, you're going to recopy what you wrote for the first 2 questions on page 9. All right, so the answers that you wrote for the first 2 questions on the bottom, page 10, correction. The first answer you wrote for the bottom of page 10, you write for the first 2 on the bottom of page 11. All right, so why is ionization energy decrease and electronegativity decrease is moved from right to left? It's the same thing as if you moved from top to bottom down a given group. So recopy those from page 10. All right, we're going to focus on what's new now is the third question. Why does atomic radius increase as you move from top to bottom? Why is it getting bigger? All right, you should already know that by looking at the periodic table. Okay, that's from before. Shells. Li only has how many shells? 2-1, that's 2 shells. Okay. So Li has 2 shells, right? 1, 2. That's why its radius is 130. Na has 3 shells, right? 2-8-1. That's why its radius is 160. K is bigger, it's 4 shells, 2881. So it's a radius of 200. So why does the atomic radius increase as you go from top to bottom down a group? It's because you're getting more shells. So just write because you're getting more shells. All right. And this concludes our video for page 11.